All right, we're going to take a look at Unit 1, Day 3 over angle classification and angle relationships. Our objective for today is to measure and classify angles, and we'll also be identifying and using special pairs of angles. So this is what you should be able to do by the time we're done with this lesson. Now, you may have some questions over this video after you finish watching it. That's okay, it's intended. Just make sure you bring in your notes ready to ask those questions next time we're in class. So we're going to start off by just reminding ourselves what an angle is, okay? We talked about that on Day 1. And so we know that an angle is formed by two rays with a common endpoint. So that's what we're going to write here. An angle is formed by two rays with a common endpoint. All right? And we know that it's measured in degrees. Okay, we'll use this little circle symbol to show degrees, as you can see here. All right, and so we've got some other various classifications of angles that we can talk about. Any angle that has a measure between 0 and 90 degrees is called an acute angle. If the measure is exactly 90 degrees, then it's a right angle. If it measures greater than 90 degrees, it's called an obtuse angle, but it has to be less than 180. And if it's exactly 180 degrees and looks like a straight line, or opposite rays, remember there's that term, and then we call that a straight angle. Now, many pairs of angles have special relationships, and so that's where we're going to take a look at this for the rest of the lesson, either because of their measurements of the angles or their positions in relationship to one another. And so we're going to look at some positioning relationships first. Okay, now here we've got two kinds of pairs of angles based on positions, and you can find this same information on page 28 of your textbook. If two angles are going to be adjacent angles, that means that they are two angles with a common vertex and a common side. Okay, so you'll see that there's our common vertex and there's our common side. So those are adjacent angles. 1 and 2 would be considered adjacent angles. And this is abbreviation for adjacent. Now, if we have adjacent angles where the non-common sides form opposite rays, we can call that a linear pair of angles. And that's the abbreviation for linear pair. So you can see that these angles, they share common side here between 3 and 4. There's a ray going between angles 3 and 4. They both share that side. But the other sides of angles 3 and 4 form these opposite rays. That's a linear pair. This is just adjacent. This is also a linear pair. Okay, now before we go a whole lot further, I want you to think for just a second, if you can think of an example when two angles would either have, part A, common vertex but not be adjacent, or part B, a common side but not adjacent. Okay, try and think of an example. If you need to scratch some stuff down on your paper, you can. If you need some more time, pause the video. But you might think of something like this. If two angles have a common vertex but they're not considered adjacent, they might look like this. There's angle 1, and I'm going to create another angle with that same vertex, but they're not going to have either of these sides in common. So angles 1 and 2 have a common vertex, but they're not adjacent because they don't share a side. They don't share one of those rays. Now, I have this third angle that I haven't numbered that would be adjacent to 1 and 2, but right now 1 and 2 are not adjacent. Now, if we have a common side but not adjacent, that might look something like this. Let's see, there's angle 1. But let's say I put a vertex of another angle here. So they share this ray as a side, but 1 and 2 are not adjacent because they don't share a vertex. So it might look something like that. All right, let's keep right on moving. In example 1 then, we're going to take a look at this picture and try and find some pairs of angles and figure out if they are only adjacent. In that case, we'll write A, D, J. Or if they are adjacent and form a linear pair. Or if they're just not adjacent. Okay? So let's look at angles 5 and 6, for example 1A. Here's angle 5, here's angle 6. They have a common vertex and they share a side. So that makes them a linear pair. So these are adjacent and a linear pair. And I'll abbreviate to save some time here, so you can abbreviate also, just as long as you know what those abbreviations mean. Then if we look at angles 7 and SPU, I'll trace that one for you. They used this notation for angles because SPU contains angles 5 and 7. Now, angles 7 and SPU, they do share a vertex at P, and they do share this side, but angle 7 is inside angle SPU. And that means they have common interior points, and we're not supposed to have common interior points for them to be adjacent. So these are not adjacent because they overlap. Okay, any angles that overlap like that, where one is inside another, are not considered adjacent. 5 and 7 would be adjacent, but not 7 and SPU. And then if we look at angles 7 and 8, they share a common vertex, but they do not have a common side. So these are also not adjacent. All right? All right, let's go ahead and turn the paper over. And we're going to start talking about another pair of angles. We can pair angles up and call them complementary or supplementary, and these pairs are based on the angle measures. Notice in these examples, I have not drawn adjacent angles. Complementary and supplementary don't have anything to do with where the angles are positioned. It's only about their angle measures. So if we look at this, we've got complementary angles if the two angles have a sum, and remember sum means addition, of 90 degrees. So if I add two angle measures up and get 90 degrees, then they're considered complementary. If I add two angles together and I get a sum of 180 degrees, they are considered supplementary. Complementary and supplementary. All right? So looking here, if you added some values up together, A and B, 37 plus 53, that equals 90. So A and B are complementary. But 127 and 53 add up to 180, so those are supplementary. So angles A and B are complementary. Angles A and C are supplementary. When we add those together, you get that. All right? So if I were to ask you what the supplement of an angle is, you would take 180 and subtract that angle. If I asked for the complement of an angle, that means I take 90 and subtract that angle to find its complement. All right? So we're going to practice that. So in example 2, we're asked to find the measure of each of these followings. Okay? We're supposed to find the complement of angles E and F. These are two separate problems. They are not going to go together. So to find the complement of angle F, complement means we're using 90. We're going to do 90 minus 59. And we get 31 degrees. So the complement of angle F is 31 degrees. That means an angle measuring 31 degrees would be complementary with angle F. But when I'm given an algebraic expression and no other information, I cannot get a final answer like this. I'll get a simplified expression, but not an exact number. So to find the complement of angle E, I'm going to do 90 minus this expression. And whenever we do that subtraction, we have to distribute the minus sign to the 7x and to the negative 12. So we're actually doing 90 plus 12, because minus a negative 12 gives you plus. 90 plus 12 is 102, and then I have minus 7x, and so the complement to angle E would be this expression. Okay? On part B, for a supplement of these angles, we're going to use 180 instead of 90. So we're going to do 180 minus 116.5 to find the supplement of angle F. And that gives us 63.5 or 63.5 degrees. And on this one, we're going to do something similar to angle E over here. We're going to do 180 minus the quantity 7x plus 10. Remember to distribute that minus sign. So we actually would write it long ways as 180 minus 7x minus 10. And 180 minus 10 is 170. So that supplement, rather, is 170 minus 7x. All right, let's keep moving right along. Now, Those are pairings of angles based on measure and positioning, but we have another problem to look at. If we look at example 3, we have a word problem that tells us to relate an angle and its complement together. And so I'll let you read along with me. An angle is 10 degrees more than 3 times the measure of its complement. So we want to find the measure of the complement. Well, the best way to do this is to come up with some definitions first. And by that I mean we're going to use a variable to represent some angle. Let me rewrite that. Then to talk about its complement, ignoring the rest of this, we just need to remember that to find an angle's complement, we subtract it from 90. So anytime we see an angle's complement, we're going to use that expression. Anytime we refer to just the angle, we're going to use that expression. So when it says an angle is, we're using x. So we write x equals for an angle is. Then we're going to do the rest of this. 10 more than means we're going to take 10 and add it to something. 3 times the measure of its complement. Where we see its complement, that's where I put in that expression. So I need to be able to do 3 times the measure of that, and then add 10 to that. So I've created an equation to solve to make this a little bit easier. First thing you should do is distribute. Then combine these like terms. Then add 3x to both sides. It gives you 4x equals 280. Then we're going to divide by 4 on both sides to get our x value of 70 degrees. Now, the problem says find the measure of its complement. We found x. X is the angle. So the complement means we take 90 and subtract x. So 90 minus 70 is 20 degrees, and that's the answer to your problem. All right. Let's quickly try and get through some more of these. We also want to talk about what are called vertical angles. Now, in a diagram like this, we have linear pairs of angles like 1 and 2, or 1 and 4, or 3 and 4, or 2 and 3. But vertical angles are the ones that do not share a common side. So in this case, 2 non-adjacent angles formed by 2 intersecting lines are called vertical angles. And vertical angles are always congruent, which means they have equal measures. So angles 1 and 3 have the same measures. Angles 2 and 4 have the same measures. We would call 1 and 3 vertical angles, and we would call 2 and 4 vertical angles. So for example 4, I would like for you to name a pair of vertical angles. Pause the video so you have enough time to do this. All right, if you need more time, you can continue to keep the video paused or pause it again, but otherwise you should see something like this. Angles HML and angles JMK are vertical angles. Now notice how I wrote them with their 3 letters. Okay? Now, I want to find the value of each of these variables in this problem. We're actually going to come back and do this one in class, all right? Unless I'm mistaken and I have more time in the video. But we'll come back to this one either in class or later in the video. We'll see how this plays out. But I do want to get on to this back page. All right? So in example 4, we want to figure out if we can actually determine these things from the given information. All right? So we want to determine whether each of these statements can be assumed from this figure. First of all, can we determine BFC and AFG angles are complementary? BFC and AFG. Well, they are not vertical angles. They are not giving me any information about their measures. So we cannot assume that they are complementary. We don't have enough info. All right, and then we are given angle DFA and angle AFG. Can they be assumed to be a linear pair? Well, they have a common vertex and they share a common side. So yes, they can. All right, and lastly, DFC and BFC, we want to figure out if they can be assumed to be complementary. and they are part of this right angle. So yes, they can be assumed to be complementary. All right, because they're part of a right angle. All right, so hopefully that helps you a little bit. All right, now, the end you'll see here is that we have a section of thinking questions. We're going to use these as your warm-up for the next class period. So don't worry about working those out yet. You'll do those in class as your warm-up, but it's going to refer back